sometimes we talk about measuring the osmolarity of a solution by measuring its sort of osmotic pressure. Osmotic pressure is the force with which water is being pulled toward this higher area. So the steeper the gradient, the greater the pull, right? So the higher the osmotic pressure. Pressure measurements are different. We could measure that osmotic pressure as the force I would have to apply on this membrane to prevent these molecules from moving. Right? So I could provide pressure here to push them back. Obviously, the steeper the gradient, the more pressure I have to push back. So sometimes we talk about osmotic pressure as that kind of pull or tendency of water to move. The only reason I mention it is because it's different units. The units of osmotic pressure are going to be millimeters of mercury or torr, something like that. And when we talk about exchange across capillaries, we have to talk about osmotic pressures and resolve some opposing pressures, and that's where you'll see that terminology. But just think of it as, you know, the force you'd have to apply to prevent water from moving. So the greater the osmotic pressure, the greater the pull of water, something like that. That's that. Now, we're often comparing two different solutions in our body, right, that are separated by a membrane. We have a membrane here, for example, like this, and we have a certain amount of solutes on one side and a certain amount of solutes on the other side, and water is going to move. Right? Now, a solution that has a high concentration of solutes, so a high osmolarity, is called hyperosmotic. So if there was a gradient here, this would be hyperosmotic, this would be hypoosmotic. If they were equal, and there's no net movement of water, they would be isoosmotic. Meaning that we have the same concentration, the same osmolarity on either side. So hyperosmotic, high osmolarity, hypoosmotic, low osmolarity. If the osmolarities are the same, isoosmotic. Now water will tend to move toward the hyperosmotic area, right? And this solution here, if we had a gradient here, let's say we had a high concentration of solutes here, and a low concentration of solutes here. There's my membrane. Water is going to move from here to here. Right? This solution gained water, this solution lost water. Solutions that gain water are called hypertonic. Tonic is the Latin for water. This gained water, so it's hypertonic. This lost water is hypotonic. You guys okay with that? Is that all right? We're building